Learning Objective 2 from Section 4.2 is to apply concepts of sampling distributions to calculate and interpret probabilities associated with the sample mean and to find values of the sample mean for given probabilities in context. The number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate cookies is approximately normally distributed with a mean of 1262 chips and a standard deviation of 118 chips, according to a study by the U.S. Air Force Academy. What is the probability that a simple random sample of 49 bags results in a sample mean of at least 1,300 chocolate chips? Include an appropriately labeled and shaded sketch of the distribution in your solution. Report the probability to 4 decimal places. All right, I've opened up the GeoGebra probability calculator. I'm in the distribution tab. We've used this before, even for this very example in previous videos. We're going to use the normal distribution and we're going to enter in the mean, which is 1262. That doesn't change even though I'm talking about the sampling distribution, because the mean of the sampling distribution of the sample mean is equal to the mean of the population. But the value that we're going to input for sigma does change. Remember that the standard deviation of the sampling distribution of the sample mean is equal to sigma divided by the square root of n. So I'm going to use the GeoGebra calculator and let's calculate that. They tell us that the standard deviation is 118. But then we need to divide by the square root of our sample size, which is 49. And let's write that, whoops. As a decimal. There we go. So I can use this right arrow to move it from the fraction format to a decimal format. So 16.857. Let's enter that in as our standard deviation in the probability calculator. Okay, so that's the value for sigma that we'll use because we're talking about the mean of a sample. So notice it says here, sample mean. I want the probability of at least 1,300 chocolate chips. So I'm going to click on the button that will shade to the right, and then I'm going to enter in 1,300. It's just this very small area in the right tail, and you can see the probability here is 0.0121 rounded to 4 decimal places. I'm going to try to write that a little bit neater, 0.0121. Okay, now let's interpret that probability. If 1,000 samples of size 49 bags were obtained from this population, we would expect blank samples to have a sample mean of at least blank. So I'm going to take my 0.0121 and go to the thousandths place, which is the 3rd decimal place. If I go to the thousandths place, I have 12 out of 1,000. 12.1 out of 1,000, but that would round to, we would expect 12 samples of these 1,000 to have a sample mean of at least 1,300 chips. That's the shaded area that we have in our GeoGebra output. So you could sketch that little shaded area, but GeoGebra will give that as well. That's the distribution or the sketch that we would be looking for. Okay, let's look at the next question. The total energy need during human pregnancy is normally distributed with mean mu equals 2,600 kcals per day and standard deviation sigma equals 50. Find the probability that a random sample of 27 pregnant women has a mean energy need of less than 2615 kcals per day. All right, so we're going to do the same thing, except for now, in our probability calculator, we will enter our mean of 2600. We'll need to compute our standard error of the sample mean. So they tell us that the standard deviation is 50, but we are going to divide by the square root of our sample size, which is 27. And we get 9.623 rounded to 3 decimal places. So let's change this value for sigma to 9.623. And then we want the area that's to the left of less than 2,615. There's our shaded area, and here's our probability, 0.9405. Find the probability that a random sample of 27 pregnant women has a mean energy need between 2590 and 2620. So now I'm going to click on this middle button here, and I'm going to change these values to 2590 and 2620. And I get 0.8318. One comment before we move on. The sample size here was only 27, which is less than that 30 cutoff that we need for the sampling distribution to be approximately normal, so that it's okay for us to use this normal distribution in our probability calculator. However, we were told that the distribution is normally distributed, and so even though our sample size is less than 30, we are okay to use the normal probability calculator. Okay, last question. Assume that blood pressure readings are normally distributed with a mean of 117 and a standard deviation of 9.6. If 144 people are randomly selected, what is the blood pressure reading such that there is a 20% probability that the sample mean is above it? In this example, we are given a percent, 20% above the value that we're looking for. So now I have a value to go in this rightmost box, and I'm looking for the actual data value that will go in one of these boxes here. I'm interested in an area to the right of 0.2. Let's enter in what our mean should be. They tell us that the mean is 117 for blood pressures. We'll need to compute our standard error of the sampling distribution. So we'll come back here one more time. We'll enter our standard deviation, which is 9.6. We will divide by the square root of our sample size, which is 144. And that will give us 0.8, which we will enter in to our value for sigma here. 0.8. And now I want to have 0.2 to be this shaded area. So I'm entering 0.2, and that gives me what value is right here along the horizontal axis, which is 117.67. And so that's our answer to this question here. There is a 20% probability, that the sample mean of blood pressures will be above 117.67.